The reflection of a wave is the bouncing back of the wave when it hits a barrier. In reflection, some or all of the wave may be reflected. In reflection, the wave travels in only one medium. Therefore, the speed is constant. The speed, which is calculated from the product of the wavelength and the frequency, is constant. When the wavelength increases, the frequency decreases, and vice versa. That's why the speed is always constant. There are two types of waves in the reflection. The first one is the incident wave, or the initial wave that travels towards the barrier, while the reflected wave is the wave reflected from the barrier to the initial position. There are two types of reflection here in the reflection of the waves. The first one is the reflection of the wave with a fixed end or an immovable barrier, and the next one is the reflection of a wave with a free end or a movable barrier. In this project, I was only able to make the reflection of a wave with a fixed end. And reflection of the wave with a fixed end, there happens to be a 180 degrees phase inversion, wherein the crest will be reflected as a trough and the trough will be reflected as a crest. Here is the example video. For the free end or the movable barrier, there is no occurrence of a phase inversion. The crest will remain as a crest and the trough will remain as a trough. Refraction occurs when a wave travels from one medium to another. In refraction, there is change in the inertial property. Also, in refraction, the speed is not constant since um, the wave travels from one medium to another. The speed is dependent on the wavelength because here in refraction, the frequency is constant. Refraction occurs in two ways. For the first one is the low inertial property to high inertial property, wherein a part of a wave is transmitted and the other is reflected. When a wave travels from low inertial property to high inertial property, the high inertial property part acts as a barrier. This is where the small amount of energy is transmitted, and the remaining energy or the energy left over is reflected back. In this type of refraction, the amplitude decreases and the speed also decreases. For the next one, we have the high inertial property to low inertial property. In this type of refraction, there is no phase inversion. Also, there is a huge amount of energy transmitted rather than reflected. That's why there is uh, an increase in amplitude and in speed. Wave interference is a phenomenon that occurs when two waves traveling in the same medium overlap with each other. In wave interference, there are two types. The first one we have is the constructive interference, wherein similar parts of the waves overlap, thus forming a higher amplitude. For the interference to be constructive, the phase difference must be even multiples of pi, or the phase difference must be in the form of 2n pi, where n is any real number. For the next one, we have the destructive interference, wherein the waves are 180 degrees out of phase. And when the waves interfere or overlap with each other, the result is that the waves cancel each other. It means that the crest meets a trough and a trough meets a crest. For the phase difference must be uh, add multiples of pi or is in the form of quantity 2n plus 1 times pi, where n again is any real number. Here is an example. Thank you for watching my project in Advanced Physics 10. This is Ethan C. Filio signing